Intel's next-gen processor, Panther Lake, is the next chapter in this amazing story that has become an integrated graphics journey. I'm Alejandro Hoyos, and this episode of Talking Tech, I get to sit down with Tom Peterson and talk about all the different technologies that have evolved throughout the years and how these technologies have become the building blocks of what it is today, our processor integrated graphics. Join me on the road to Panther Lake.
Intel's integrated graphics strategy started way back on use white space in the CPU to be able to run games and do display. And we've decided over multiple generations that actually investing in integrated graphics and really beefing it up delivers great performance in a very power efficient way. So you can have great gameplay, great creator applications, but you also have long battery life. You know, you traditionally think of graphics as gaming, but as AI PCs continue to grow in the use cases and demands grow with them, our GPU runs about half of the AI features in prior generations, and that will continue with Panther Lake.
Well, where did this journey begin here for Intel and graphics?
Well, a lot of people don't know, but Intel is not only one of the largest graphics companies in the world, but we've been doing it almost longer than anybody, more than 20 years. And in the beginning, we were focused on building graphics IP that would allow us effectively to light up displays for common PCs. So the workload for graphics was very simple for many years, and our target was to make IP that was small and power efficient to live alongside of our CPUs that were doing most of the work in PCs. So that's kind of where the story begins.
So that's when the story begins. So we have kind of these very different workloads back at the beginning.
Exactly.
And as we have come, I guess, moved forward in time, we have seen that not only the workloads have changed, there has been new things added to it, games have become more demanding. So what happened then?
Oh yeah, well you can kind of fast forward through, the 2000s, and suddenly towards the end of 2000s, graphics becomes much more important. Gaming becomes the biggest industry in the world, and people want to play games on their PC and they want to play games in mobile form factors. So Intel took a big step back and made a big investment in upgrading our graphics IP so that we could provide high performance gaming and still be power efficient. But the problem with us initially is that's a big change, right? We had been making smaller GPUs that shifted a lot of the work to the CPUs, so we were effectively CPU bound on our workloads. And even though we had a GPU, it didn't really get exercised as hard as you might think. When we did our first big graphics IP called XE, that XE shifted the balance of work from the CPU to the GPU. Performance went way up, but it also exposed a whole bunch of issues that we hadn't seen before that we had to work through.
Right, because that was kind of our first try at dipping into like all these big changes.
Oh yeah, I mean we started thinking about like CPU GPU balance in a new way. We saw huge amount of compatibility issues that became apparent because now we're running thousands of titles for mainstream gamers, and DX9, DX11, DX12, Vulkan, all of the different APIs all had to work on our XE GPU. And the truth is we had some gaps. And those gaps happened because we just had not been exposed to this kind of workload before. We had gaps on our gaming experience, we had gaps on our creator kind of experience, but at the end of the day, the team came together, we made a ton of improvements, and Alchemist at the end of the day delivers a great experience.
Yeah, I remember at the launch when we were still needed, like you said, kind of a backlog on games that we needed to test and a bunch of other applications. And as the time went by, we definitely improved and have more drivers, and it became a better experience.
Oh, absolutely. We took all of that learning and we did our second generation called XE2. In 2024, we launched our XE2 IP, and it landed in two different products. One's Lunar Lake for integrated, and the other one was Battle Mage. Right. Now, when you think about what is the team doing during that time, we're taking all the learning from Alchemist and we're applying it to XE2 and Battle Mage and Lunar Lake. That's things like improving our game testing by 6x. And it's like bringing new graphics technologies to improve performance without effectively taking more power. So that thinks about like, as we move forward, we solved a lot of the problems that we had in the beginning.
No, that's pretty neat. For those who are kind of new to this, what was the changes from XeSS to XeSS2?
Oh, XeSS to XeSS2. Well, that kind of brings us back to this whole question of AI. So if you remember, AI sort of started emerging for us around 2015, 2016. And by the time we got to XE2, we realized we really had to lean into AI. So with XE, our first architecture, Alchemist, we introduced a technology called XMX. And XMX is a hardware block that does a systolic style of computation. And that is the fundamental mathematics, which is a matrix operation that drives AI. So building real hardware to do AI acceleration dramatically boosted our performance, and we built a technology around it for gaming called XeSS. XeSS is our first take at neural graphics. It does traditional raster to generate a base image, and then uses AI to scale it up and get you higher performance at lower power. Now that XeSS sort of super sampling technology migrated and kind of evolved into what we call XeSS2. And XeSS2 added a couple of really cool technologies. One I'm super excited about called FrameGen, where effectively you take one frame and you predict using AI what the next frame is going to look like. And another one was low latency technology, where we're effectively sort of reducing the latency from the time an image is produced until a gamer can see it. So all of these technologies together are XeSS2. And that was a big step forward as part of our XE2 architecture.
No, it looks great. So we started with the XE, which was, if I'm not mistaken, it's Meteor Lake, and then all those learnings, we moved on to our next processors.
Lunar Lake, Battle Mage, yeah.
And so we have all that. What have we learned when it comes to, I mean, like we mentioned before, like ISV enabling and software development kits and things
well,
like
let's just think about XeSS. You know, when we started, we're kind of small in this space. So we have to go out to developers and say, hey guys, we have a new technology. It's called XeSS. Can you modify your game and integrate this technology? So it's always hard to do that. But by now, I can tell you that we have over 600 games integrated with XeSS, which is really kind of incredible. And we have more games, around 60 games that have already integrated XeSS2 with FrameGen. So our engagement with the ISV community, as we've iterated through our graphics IP, has really, really ramped up. And I'm really excited to say that we have a current engagement for Battlefield 6 with Dyson EA. And that's like we get early builds in, we're iterating, we're integrating our technology, and we're going to deliver just a fantastic experience with that game at launch.
Right. So there's a lot more collaboration, closer work with the developers to make sure that when the game launches, we're ready to go.
Absolutely. And you can think of that engagement is just one example, right? We do CPU optimization, we do power optimization, and our team is looking at multiple different form factors. You know, we look at laptops, but we also now look at handhelds, working with OEMs to optimize the performance of all these new games and workloads. It's a massive, massive upgrade from where we were several years ago.
Right, so that's where you're looking at, like, our newest architectures are a lot better when it comes to, I think we're talking about area and power.
Yeah, it's better from what I think of as perf per watt. So effectively in a power budget, we're going to deliver more performance, which is great for mobile form factors. But we're also better from a perf per area. So if you have a certain amount of silicon area you want to dedicate to graphics, we're going to deliver much better performance than we used to. So I would say the team in general has evolved as we've gotten more and more expert in the workloads we're targeting, which are AI and graphics.
Yeah, I was pretty excited to see, like, when we started to move into the handheld devices, it was pretty good to see, like, the evolution from Meteor Lake to Lunar Lake.
Did you play with the?
Yes, yeah. I have the Claw 8, which in my house, and that's what I take when I travel a lot.
It's pretty cool. You know, another learning for us is when those form factors first started emerging, similarly, we hadn't seen them before, so we had a lot to learn. We had a lot of power optimization to do. We invented some new technologies that do sort of system-level power management for those handheld devices. And we're basically able to improve performance by around 10% without increasing any power draw. So people don't even see this, but as we go from driver to driver to driver, we're always making things better from either a performance perspective or a perf per watt perspective.
Yeah, it's pretty important, like, to keep, we'll always keep your drivers up to date on all the firmware and everything, but I think it's great, all the like you can see how much the performance has improved from one driver to another, and it just shows how much we are learning.
Absolutely. Another great example is the product that we have called Intel Graphics Software. That's sort of like our control panel, how you configure our GPU. But we've added a new technology in there which allows an end user to adjust how much graphics memory they're dedicating to the GPU. So Windows has a default that's around 57% max for system memory that's allocated to graphics. But when you're doing AI workloads or you want to just get the maximum gaming, you may want to like take a lot more memory and dedicate it to graphics. And now we allow an override in IGS. All that comes from learning, hey, you know, Windows is making this choice. What can we do, even in the face of that, to make it better?
Yeah, it's been great to see how the reception has been from when we started all the way to today on how you know, people have received pretty much they've been growing up with us, which is really nice.
And I'm grateful for all the support we've had from the community. But the world wants there to be more technology, right? The world wants more technology providers. And that's what we're doing. We're building technology that is inexorably going to become the dominant form of the technology in the market. And people constantly kind of get confused about how big is our footprint in the market. And I can say without a doubt, we are the largest.
Yes, yes. I mean, when you start thinking about it, like integrated graphics a long time ago, there will always be there.
Yeah.
And now moving forward, we're making big strides.
Huge, huge. I think AI is the topic that, you know, we personally have really embraced, not just in neural graphics, which is the blending of AI and graphics, but thinking about AI on our CPUs, right? So with our GPU and our NPU, we're really focused on enabling that next generation of AI experience on the PC. I think of the biggest transition in PCs is yet to come,
right,
which is this idea of agents that are being explored right now. If you don't know, agents are like this idea that your PC and the logic running on your PC can act on your behalf given very simple commands. That behavior is going to change the way you experience PCs. And we are right in the middle of that, Alex, and it's going to be terrific. So AI accelerated by our NPUs and our GPUs and our CPUs is going to change the way PCs work forever.
I think it's going to be great because, like you said, we're having that transition of coming like all these workloads from the cloud to your PC to be actually to agentify. I don't know.
I think I just think of it as agents, native agents, right?
Yep.
And the reason agents native are so important is because of economics. You know, if you're running cloud-based agentic workflows, that's very expensive for somebody. You know, people don't want to pay for that, and the cloud service providers don't want to pay for that. And that's where Intel steps in and deploys vast, large amounts of silicon to run agents locally and effectively enable that next generation experience.
And it's been great because we've seen how we have been trying to improve across. I mean, you have to do a lot of stuff in the software stack to do that, and then also have the engine, like the hardware, to do that.
Absolutely. I want to give a small plug to OpenVINO, which is a team that we have that is basically building the execution provider, or think of it as like the engine that does inference across all of our different IPs. That team is critical to enabling agentic experiences on the client.
Yeah, I can't wait to see that, and it's going to be great. Anything about what's next?
What's next? Well, I would say larger investments in graphics and AI. And so if you imagine in a PC, this workload is not going away, right? The world is becoming more graphical. The world is embracing AI at more rapid than any other technology ever. So I would expect Intel to respond to that, right? It's not like we have to guess what is big and what is coming. We know, and what's coming is more AI and more graphical experiences.
The graphics in Panther Lake is going to set a new standard for us, and we actually think for the industry, and we'll talk more about it when these products are ready to launch.